Another thing that's very important about initial and terminal points on the unit circle is the distance that they are apart. And this is all probably seeming kind of strange right now and a little bit weird, but I promise that this is very important for understanding the basic trigonometric functions and how they work, which we're almost to. So next up, let's kind of practice and discuss, well, but say for example, between the initial point of 1 comma 0 and the terminal point of 0 comma 1, how far apart are they? And a key property of the unit circle is the fact that its circumference is 2 pi, meaning that the distance all the way around. So say for example, the ant was to go all the way around and do one complete circle, that distance would be exactly 2 pi. Um, so let's review why that is and talk a little bit about pi and circles because there's a little bit of interest. There's some interesting stuff in there. But let me go back to the slides real quick, and I'll show you a quick graphic about why, what's why is that true. And I want to just talk about pi for a minute, not the include the pi, but if in this graphic you can kind of see, say we start with the center of a circle and move a distance 1 away from it. This is pause. Let's see if I do any. And we're to trace a circle around distance r. Again, on the unit circle, let's say that that was distance 1. And now technically this graphic is not necessarily for a radius 1, but if we're pretending as we're tracing around the circle, notice that if we move a distance 3, it doesn't quite make it to the halfway point. And what pi is the exact distance you need to move halfway around the unit circle. Obviously 2 pi would get you the full distance, which is a helpful way of seeing why 2 pi makes a complete circle. Uh, and that's why the unit circle's circumference is 2 pi. Pi in general, the pi is a number that's very popular in our culture, and it's going around as kind of one of those interesting numbers. But it's an irrational number, much like square root of 3 or other numbers we worked on when we're dealing with polynomials. But it's an infinitely repeating number with no discernible pattern to it. And obviously, it's a number that just doesn't work very well. Early man was really obsessed about understanding pi because of the importance to circles in engineering and construction, and well, the wheel, of course. But the circle is a very important invention, geometric invention in the context of human history. And early man wanted to understand the relationship between lines and circles. Like, what is this? Like one of the early approximated ratios between circles and lines. People approximated this relationship to be around 22 over 7. If you type in 22 over 7 in your calculator, you'll see that it comes out to be very similar to pi, which for a long time people thought maybe this is pi, or um, or they just assumed. Or 3 was another very early approximation. But over time, we've come to understand that there is no rational relationship, there is no direct ratio between lines and circles, and that is what pi is. It's the numeric relationship, which is why things like your circumference and area, area equal pi r squared, circumference equal 2 pi r, they all relate back to pi because it's just a number that's always present with circles due to nature. And so a lot of people attribute this to God or something because there's not really a better explanation. Well, why? It just is. It's something that exists. Um, and often how we do it in trigonometry is we just leave pi written using the Greek pi symbol as opposed to writing it out because the number is so horrible. But in its form, pi or pi over 2 or 3 pi over 4, it is easier to work with. It's also, pi is a transcendental number as well, much like e, and I probably talked about this a few weeks ago when we were talking about the number e. But it's an irrational number, but it's not an algebraic number. It's not like the solution to a quadratic equation. It's kind of its own category of weird numbers. Like if you type in the square root of 3, it's another really weird number. Anyways, uh, pi is important with trigonometry and with the unit circle because it's a circle, it's going to involve pi. So if we do a full circle, there we go. So let's get back to the packet, and I'm going to stop rambling. Off. Okay, and let's look at a couple more examples. So what it says to do is find t, the distance to the terminal point from the initial point for each of the following points. So the initial point, to review, is right here. The circumference is 2 pi, or is 2 pi of the entire circle, if you want to write that as another fundamental fact. But let's say, for example, we wanted to not do the whole circle, which we know to be 2 pi, but do other parts. So let me actually move to the whiteboard instead. But if we wanted to try to solve what's the distance from the initial point to the terminal point 0, 1, well, notice that since a full circle is 2 pi radians all the way around, another thing about that is, well, half of a circle is pi radians around. Again, it just is. There's not really a better explanation than that. And so if we were to do only half of that, i.e. focusing on just, oh no, I don't want to do that. Gross. But if we were just focusing on the distance from 1, 0 to 0, 1 on the unit circle, that would be pi over 2 radians, and I haven't defined what does radians mean. We're going to come back to that in a different video, but basically the distance from the initial point to the point on the top is pi over 2. So that would be the answer to A. Part B asks, well, what is the distance to 0, 1? Oh, that is part B. Oops, I lied. But basically the distance, so trying to take better notes than I'm following here. And I'm going to write it as t is equal to pi over 2. That would be the distance from 1, 0 to 0, 1. And in your try it yourself quiz for post-lecture, it'll ask you questions kind of like this. What is the respective distance to the point from the initial point? And that's what I'm asking here, which is often written as pi over 2. But for part A, it asks us what is the distance to 1, 0 over here, but that would be pi, because halfway around the circle, it takes a distance pi to go all the way, not all the way, but halfway. And really, the entire circumference is 2 pi. Half of 2 pi is pi, which is why the distance to negative 1, 0 is pi instead. Color here to follow what I'm doing. And then for number C, it asks what's the distance from the initial point to 0, minus 1, the one at the bottom, which since the distance halfway around was pi, if we then wanted to continue going to 0, minus 1, that would be another pi over 2 plus pi. So if we were to do that one, the distance would be pi plus pi over 2. Since a quarter of a circle is pi over 2 and half of a circle is pi, and that would give us 3 pi over 2. Well, also, dealing with fractions of pi, if we want to add these together, just like with normal numbers, you have to have a common denominator. So if we want to add them together, we would need to multiply the first top and bottom by 2 to make sure they both have the same denominator. So that would give us 2 pi over 2 plus pi over 2, which would leave us with t is equal. So anyways, summarizing, if we were starting at 1, 0, and if that ant starts walking around the circle, it's going to progress, and it's going to get, and notice that those values are getting larger and larger and larger. As the ant progresses and gets to the top of the circle, it has moved pi over 2 distance. Halfway is pi. 3/4 of the way is 3 pi over 2. And if they were to get all the way, that would be the full circumference, 2 pi. Another thing you may have been wondering is, let's say that let's say we were to go clockwise instead of counterclockwise, because it kind of makes sense to, instead of going all the way around the top, to just go clockwise to get to that point as well, which is allowable. It's fine. If you want to get from the initial point to the terminal point, you can go any way you want, and there's not a unique solution to this question. But notice that since that is, as I said, I think in the last video, is defined to be a negative when we go clockwise. And notice it's also a quarter of a circle, so that distance would be the same as going upwards, pi over 2, but it would be defined to be negative instead. So technically, this is an idea which is called coterminality, but this point, 0, comma minus 1, is defined by two different distances. You could either go counterclockwise a distance 3 pi over 2 to get there, or clockwise negative pi over 2. We're going to wind up in the same point, and that point would be called coterminal. So technically, it's like two different ways of getting there, but the same point. And that's a good spot to leave off this video.